Hi, this is Divya, Assistant Professor, Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about, this is the continuation of the previous video where we are talking about the PN junction diode. Okay, here, the need for semiconductor solutions. Why do we need these semiconductors? Semiconductors, we know that the semiconductor is a conductor which should conduct electricity to a certain point, and after that it acts as an insulator. That material is called a semiconductor. Okay, we'll see what all the semiconductor solutions we have. Okay, vacuum tube limitations, signal processing challenges we have, miniaturization demands. These semiconductors to be designed in a very minimum, the miniature size of the device should be very minimum nowadays. We are designing it to a nanoscale level, right? So the efficiency, we have to increase the efficiency of the device, and the size of the device should be also very minimum. Okay, like if it is so, that the semiconductor solution, the semiconductor area will be a very big one, which is developing which is developed and developing in the near future also. Vacuum tube limitations. What is vacuum tube limitations? Early medical electronics relied on bulky vacuum tubes consuming excessive power, generating heat, and requiring frequent replacements, impartially for portable diagnostic equipments. In the early medical devices, okay, we have been used the vacuum tubes where the size of the vacuum tubes will be very big, and the usage, it produces heat, it generates heat, excessive electricity it acquires, and these are the limitations of the vacuum tube which is used in the early stages. Okay, the next is the signal processing challenges. How the early stage signal processing challenges has been developed, has been incorporated in the early stage. Signal processing challenges. Biomedical signals, that is ECG, EEG, EMG, requires precise rectification and filtering. Okay, why? Because the ECG is for the heart, where we should analyze the heart rate and the heart pumping is to be in a very precise form, or else the result of the patient will be in a different form. Okay, EEG, it is for brain. Okay, where the brain signals has been acquired, and according to the brain, how the brain functions. These are very prominent areas where it is to be taken care of. Okay, the next is the EMG, that is a muscle one. Okay, electromyography. Okay, where the muscle pulses can be taken, and it is also be analyzed how the muscles of the patient is working or something like that. Requires precise rectification and filtering. Mechanical switches and relays lacked the speed and the reliability need for real life psychological monitoring. Okay, mechanical switches and relays lacked the speed and reliability needed for real life psychological monitoring. Miniaturization demands. The size of the device should be very minimum. Implantable devices like pacemakers and insulin pumps requires microscopic energy efficiency components. Traditional electronic elements could not meet these stringent size and power constraints. Implantable devices like pacemakers and insulin pumps requires microscopic energy efficient components. Okay, here we can see that vacuum tubes, transistors, and modern ICs has been how it has been developed. Bulky, hot, power hungry transistors to a smaller size, reliable and efficiency. Modern ICs, microscopic, highly efficient. These are develop how it is and how it works in the early stage and how it is transmitted in the near future. Next is the semiconductor fundamentals. As I told you already, we have the intrinsic. It is a type of intrinsic and extrinsic, or the types of semiconductor devices.